Well, I'll present our research on how information accuracy enables autonomy for wheelchair users in accessible taxi services. So our paper is titled Accuracy as Autonomy, How Reliable Information Enables Choice in Wheelchair Accessible Taxi Services. Starting with motivation, transportation accessibility is critical for wheelchair users' independence. In Seoul, wheelchair users face significant barriers in public transportation, as only 39% of buses are wheelchair accessible and subway gaps remain unsafe with ongoing discrimination. These challenges make public transportation extremely difficult to use. As a result, wheelchair users must rely on wheelchair accessible taxis as a crucial alternative. To book these taxis, they use a dedicated app called SWAT, the Seoul Wheelchair Accessible Taxi app. But the problem is that the average dispatch time already exceeds 40 minutes, which is much longer than other taxi services. Even worse, the SWAT app provides highly inaccurate predictions, with users reporting errors ranging from 30 minutes to over 2 hours between predicted and actual wait times. Because users cannot trust the system information, they're forced to rely on personal experience instead. This makes effective trip planning nearly impossible and fundamentally undermines their autonomy and ability to make independent decisions. From a theoretical perspective, transportation barriers often prevent wheelchair users from fulfilling basic psychological needs. According to self-determination theory, these include autonomy, competence, and relatedness. When you cannot trust when your ride will arrive, you lose the ability to plan independently, participate in activities, and maintain social connections. This led us to our research question. How does accurate dispatch time prediction affect wheelchair users' psychological needs and technology acceptance in accessible transportation? To understand this problem deeply, we started with formative interview with 5 wheelchair users in Seoul who regularly use wheelchair accessible taxi services. All participants confirmed substantial dissatisfaction with the SWAT app's predictions. They described discrepancies ranging from 30 minutes to over 2 hours between what the app promised and when taxis actually arrived. This unreliability made trip planning extremely difficult. Participants told us they had learned to ignore the app's predictions entirely and instead relied on their own experience to guess when to make reservations. New users without this experience would not be able to do this. The uncertainty affected not just convenience, but their ability to manage time, attend appointments, and participate in activities independently. These findings confirm that inaccurate dispatch time prediction is a major barrier to wheelchair accessible taxi usage and motivated us to explore whether improved accuracy could support psychological needs and technology acceptance. Based on this insight, we developed Groom, a mobile app prototype that provides more reliable dispatch time predictions. In the existing workflow, users directly use the SWAT app to make reservations, relying on its inaccurate predictions or their own experience. With Groom, users can first input their departure location, destination, and intended reservation time into our app, and our AI model then predicts the expected dispatch time and recommends an appropriate reservation window. With this more reliable information, users can make the informed decisions when using the SWAT app for actual reservations. For the prediction model, we use data from the Seoul's Open Data Plaza containing historical wheelchair accessible taxi call records. Since there was no prior work on wheelchair accessible taxi dispatch prediction, we evaluated several standard approaches, including ARIMA, KNN regression, linear regression, LSTM, and XGBoost. We selected XGBoost because it achieved the best performance while a mean absolute error of 13.12 minutes. This is dramatically better than the existing system's reported errors of 30 minutes to over 2 hours. XGBoost also offered sufficient interoperability and reasonable training requirements for our design evaluation purposes. So importantly, Vroom operates independently but remains compatible with the existing SWAT app. So this design choice allowed us to evaluate improved information accuracy within the constraints of the current service infrastructure. So for the user study, we recruited 41 wheelchair users in Seoul who had prior experience using wheelchair accessible taxi services. Due to the difficulty of assessing this user group, we used snowball sampling in cooperation with organizations serving the disability community. Most participants reported frequently experiencing barriers in daily activities related to transportation, running errands, and trip planning. The study consisted of 3 stages. First, participants completed a demographics survey. Including disability-related information. Second, they received a brief introduction on how to use the app, then installed it and used it on their personal mobile devices. Third, after using the prototype, they completed a post-user survey. For our evaluation framework, we use an extended technology acceptance model. This framework has been widely used to study technology adoption, and we extended it to two important components. So first, we added perceived system quality factors, specifically prediction accuracy and interface adequacy. Second, we incorporated basic psychological needs from self-determination theory, which are autonomy, competence, and relatedness. So prediction accuracy and interface adequacy represents our system quality factors, and these affect the three psychological needs: autonomy, competence, and relatedness. So these needs then influence technology acceptance measures, which are perceived usefulness and perceived ease of use. Finally, these acceptance measures drive our behavioral outcome, which is usage, continuance, intention. All survey items use a 7-point Likert scale. We analyze the data using partial least square structural equation modeling with 5,000 bootstrap iterations to ensure robust statistical estimates. So I'll move on to the results and insights section. This diagram shows our structural equation model results. First, prediction accuracy had strong significant effects on all three psychological needs. It affected autonomy with a coefficient of 0.63, competence with 0.76, and relatedness with 0.76. All of these were highly significant, and this tells us that when users receive accurate dispatch predictions, they felt more in control, more capable of planning, and more able to maintain social connection. Second, and this is our most prominent finding, autonomy emerged as the only psychological need that significantly mediated technology acceptance. Autonomy strongly predicted both perceived usefulness with a coefficient of 0.57 and perceived ease of use with 0.56. In contrast, competence and relatedness, despite being enhanced by prediction accuracy, showed no significant effects on technology acceptance. While accurate predictions enhanced all three psychological needs, only the sense of autonomy translated into actual technology acceptance. This suggests that in context with limited transportation alternatives, autonomy serves as a necessary gateway. Third, we found surprising null results for interface adequacy. It showed no significant effects on any of our variables, not on basic psychological needs and not on perceived ease of use. This aligns with our pilot study results that when core information cannot be trusted, interface adequacy becomes secondary. Users told us that a static interface means nothing if they cannot trust the predictions it displays. Fourth, the direct path from prediction accuracy to perceived usefulness was also not significant. This is crucial because it means that accuracy does not directly make the system seem useful. Instead, there's a necessary intermediate step that accuracy must first enable autonomy, and only then does the system become perceived as useful. So finally, both perceived usefulness and perceived ease of use significantly predicted usage, continuance, intentions. Perceived usefulness had a stronger effect with 0.61, while perceived ease of use also contributed 0.29. To sum up, we found a clear pathway from accuracy to adoption, but it must pass through autonomy. In contexts where users have limited alternatives and face higher uncertainty, autonomy can be the gateway through which technology becomes acceptable. So let me conclude with our key takeaways. Our central contribution is what we call accuracy as autonomy. This means that information accuracy is not merely a usability concern, but a prerequisite for autonomy itself. When users cannot trust system-provided information, meaningful choice collapses. You cannot make independent decisions when you do not know the information is reliable. What's particularly striking is that even brief interaction with accurate predictions was sufficient to increase perceived autonomy. Participants used our prototype for for only once, yet they already reported feeling more in control and more capable of independent planning. This suggests that the relationship between accuracy and autonomy is fundamental and immediate. For designers of accessible transportation systems, our findings offer clear implications. First, prioritizing prediction reliability over interface refinement. When alternatives are limited and uncertainty is high, getting the information right is more important than polishing the interface. Second, providing transparent communication of uncertainty. Users need to understand how confident the system is in its predictions. Third, offering actionable guidance that supports independent decision-making. These implications extend beyond transportation to other accessibility domains. Anywhere that reliable information enables independent planning and reduces reliance on others, accuracy becomes a foundation for autonomy. This could include healthcare appointment scheduling, accessible route planning, or assistive technology services. In conclusion, our research shows that for wheelchair users facing mobility barriers, accurate information does more than improve convenience. It enables the autonomy required for technology acceptance and sustained use. When we design for accessibility, we must recognize that information accuracy is not just about getting the numbers right, but rather about supporting human agency and independent action. Thank you.